So in class, we discovered the shape of the tangent function. This page is basically a summary of what we discovered in class. One thing we didn't talk about in class is that the tangent function is odd, which means it is symmetric with respect to the origin, and you can see that visually. But the most important thing that we talked about in class is recognizing that tangent is the special trig identity of sine over cosine. So remember, if tangent x equals sine x over cosine x, this tells us we will have vertical asymptotes where cosine x equals 0. So that'll happen here at negative pi over 2. And here at pi over 2. So vertical asymptotes always exist at pi over 2 plus multiples of pi. Now, the period of a tangent function is pi. And that period is just the distance between each vertical asymptote. And notice that that distance can change depending on our b value. Now, when we sketch our tangent function, the first thing we should find is all of the vertical asymptotes. And we know in the middle of that vertical asymptote, our tangent value is 0. Middle, oops, let me do this in a different color. This point right here is the middle of the asymptotes, all right? And we can get two other points, recognizing that at pi over 4 and at negative pi over 4, tangent is 1 and negative 1. So negative pi over 4 and pi over 4, which is in the middle of that middle. So once we have those two asymptotes and our 3 points of interest, we can sketch our curve. Now, sketching this transformation of tangent is very similar to how we sketch sine. First, we're going to locate key points that identify the intercepts and the asymptotes, and then we can find our vertical asymptotes using this function. Vertical asymptotes can be found by setting what's inside of your function equal to negative pi over 2 and pi over 2. So let's try some together now that we have kind of some background on what tangent should look like.